trigonometry. And that's the last unit of this course that we're going to cover. And trigonometry is the study of triangles. So you have triangles, and then you're going to try to be able to solve for the triangles. Okay? So we're going to learn about different rules, different formulas that we can use to solve triangles. When I say solve, I mean find angle size or find sides, how much each side is. Okay? And then we have different types of triangles that we're going to look at. Okay? The first type of triangle that we're going to look at are called the right angle triangle. What's right angle triangle? Andrew? 90 degrees. So it's a triangle that has a 90-degree angle. Okay? So that's the first type that we're going to look at. And then tomorrow we're going to look at what we call oblique triangles. Okay? Oblique triangles are all the other types of triangles that they don't have the 90 degrees. Okay? We're going to look at different formulas. What formulas can I use for the right angles? What formulas can I use for the oblique triangles? Okay? Now, first of all, we're going to look at some definitions or some vocabulary that are essential for this unit. An angle of is an angle that falls from the horizontal, also known as the angle of declination. What do you think that goes there? You can see it in the picture. So it's an angle of is an angle that falls from the horizontal. If it falls from the horizontal, that means it goes down from the horizontal. So this is your horizontal, and it falls from it. What do we call that? What do you see there? Look at the picture. So you have the horizontal, and it falls from the horizontal. Depression. So the angle of depression is always measured from the horizontal line. Okay? So you see how this right here is your horizontal line, right? And then you have the angle or the line of sight. This is the line of sight, and this is the other line. This right here between the horizontal line and the object line is called an angle of depression. So let's say if I'm standing right here and I'm looking at an object on the ground, there is an invisible horizontal line coming out of my eye of sight. I'm going to draw a line from my eye to the object. Does that make sense? So your object in this case is right here. That's your object. Okay? This is your eye. Okay? You're looking down. You have the horizontal line coming out of your eye, a line from your eye to the object, and this is the angle of depression. Okay? Now the angle of elevation is similar. It's a similar idea, except you're looking up. Okay? So I'm standing here, I'm looking at the clock. There's an invisible line coming out of my eye of sight. There is a line going from my eye to the object, and that is the angle of elevation. It's measuring up. Now in math, we use a lot of Greek letters, especially when it comes to triangles and geometry and trigonometry and angles. One of the main symbols that we use to represent a missing angle is the letter theta. Okay? So it's a Greek letter that it looks like an O, but it's called theta. And it's represented with this letter. Okay? So if you see that letter somewhere, that represents an angle, and it's called theta. So triangle that has a 190-degree angle, we call them right angle, or a right triangle. You guys remember what I said? What do we call the triangles with no right angle? Ahmed? You guys know what the word acute means? Yeah.
Smaller than 90.
Correct. So acute means, let's go back to this here. Acute angle is less than 90. A right angle is 90, yeah. And an obtuse angle is greater than 90. Okay? Now, if I have a triangle that has 3 acute angles, we call it an acute triangle. And then if the triangle has 1 obtuse angle, we call it an obtuse triangle. Okay? You can only have 1 obtuse angle in a triangle. What's the sum of all the angles in a triangle? 180. Okay, remember guys that no matter what kind of triangle it is, you're always gonna add up all your angles in the triangle and it's gonna equal to 180 degrees. So here is a right angle triangle. Okay? You have the 90-degree and the other 2 angles. Okay? To form a 90-degree, you need 2 sides. Right? So you have the vertical side, the horizontal side, and that's what forms the 90-degree. Okay? Now, you have the other side, which is the 3rd side. Now, if you look at this, do you have any angles greater than 90 in this triangle? No. If this is 90, these 2 must add up to be 90. So they could be 30 and 60, or they could be whatever, 32 and 58, or they could be anything that adds up to 90. So which side would be the longest side in this triangle? The hypotenuse, which is the side that's across from the 90. Okay? So that side right here, that's your largest side. Okay? Because that's the one across from the 90. And we call that the hypotenuse. Okay? So the hypotenuse is the longest side in a right triangle across from the right angle. Now you always, the 90-degree angle is never your focus angle. Okay? This is just a right angle. Now, in a triangle you're going to have a focus angle. And that focus angle is the angle that you're looking for, or the angle that they've given you, other than the 90 degree. Okay? So if this is my focus angle, which I'm going to call it theta, then the side across from that theta is called the opposite side. And the side next to that theta, that angle, the adjacent side is called the adjacent. Okay? If this is my angle of focus, this side is my opposite, this side is my adjacent. Now what happens if the angle of focus is this angle. What would be my opposite? At the bottom. So this is going to be my opposite, and this is now going to be my adjacent. Okay? Because this is my angle of focus, then the opposite side to the angle of focus is at the bottom now. Okay? It depends on where is your angle of focus. Does that make sense to you? So the side labeled opposite is across from the angle of focus in a right angle triangle, and the side labeled adjacent is attached to the angle of focus in a right triangle. And the angle of focus is the angle given or the angle to be found. Are we okay with this? So when we're labeling a triangle, in the right angle triangle, we're going to label them with opposite and adjacent and hypotenuse. Okay? But in any other triangles, we're going to have to label them with letters. Okay? Which means, if I have this triangle, and this is angle A, B, and C. You see, I have to use capital letters for the angles. It's a must. When you see capital letters, that means that represents an angle. Okay? Now the small letters represent sides. And if I want to name this triangle with sides, because this side is across from angle A, it's going to be called side A. This is angle B, that means this is side B. This is angle C, that means this is side C. Okay? If you're looking at this triangle, which side does it look the biggest? Side B is the biggest? Side A. Side A. Yeah, side A is the biggest, right? And it is across from the biggest angle. So you always have, if you're checking your work, you always should have the biggest angle and the biggest side across from it, opposite. Okay? And if A is 90 degrees, then yes, it will be the hypotenuse, but I don't know if it's 90, right? So the smallest angle is going to be across from the smallest side. So you see how angle B is the smallest angle, and then side B is the smallest side. Okay? So you should always have corresponding angles and sides where big across from the big, small across from the small. Okay, when a question says to solve a triangle, that means you have to find every single angle and every single side. I want to know all the measurements. Okay? Are we okay with that? All right. Couple more things. So make sure that your calculators are set to degrees. Make sure that on the top it says DEG or just the letter D, or it says you know where the sine, cosine, and tan buttons are? So you should see the sine, cosine, and tan. And then on top of the sine, cosine, and tan, you see sine inverse, cos inverse, and tan inverse. You see the sine with a -1 on top. Yeah, cos with a -1 on top, right? You see these? These represent the inverse operation of sine, cosine, and tan. Okay? So the inverse of addition is subtraction. The inverse of square is square root. The inverse of sine is sine inverse. Okay, the opposite operation. Okay, here's your rounding rules. Unless the question otherwise specifies otherwise, you're gonna round all sides to 1 decimal. Okay, unless it tells you to round it to something else. You're gonna round sides to 1 decimal, and you're gonna round angle to whole numbers. You should not have angles with decimals in them. Angles should be to whole numbers. Now, if the question asks you to find sine of 32, right? So find sine 32 for me. So press sine 32. You're gonna get lots of decimals.
Yeah.
Okay, so this answer right now, it's going to be to 4 decimal place, so 0.5. What is it? 529.
9.
What's after that 9?
1.
Okay, perfect. So this answer, when I say sine of an angle, you're gonna have to put it to 4 decimal place. Or if it asks you to find cosine of this, you're gonna have to leave it to 4 decimal place. Okay? If you're finding an angle, the angle should be to the nearest degree, no decimals. We're gonna talk about this in a second. All right. So the primary trig ratios. This is a word that you're gonna have to memorize. This is a terminology that you're gonna have to memorize. The primary trigonometric ratios. Okay? What the primary trigonometric ratios represent, they represent the sine, cosine, and tan in a right angle triangle. Okay? So, cosine and tan. So the primary trig ratios are used to find side length or angle measure in right triangles only. You can only use them in right angle triangles. Don't attempt to use them anywhere else. Alright, so first thing you need to do whenever you're using the primary trig ratios, you're going to have to label your triangle with the adjacent, hypotenuse, and opposite. So you need to label your triangle. That's your first step. Okay? So you see how you have the adjacent, because this is my angle of focus. You have the hypotenuse, and you have the opposite. That's the first thing you have to do. We're going to talk more about this in the next page. Now let's see what happens if I have the following. So I have 2 different triangles. I have triangle A, B, C, and I have triangle X, Y, Z. They're not the same length, right? They're different triangles, okay? Now, angle A and angle X are my focus angles. Why are they my focus? Because they're the ones that are given to me. how both of these are given to me, the 37. Okay. All right, so if I'm going to name this triangle, where is the hypotenuse? So this is my hypotenuse, yeah? Where's the opposite side? Where's the opposite side? 3. Because that's the opposite from angle 37, right? And where's my adjacent side? The okay? Same thing with this triangle XYZ, right? The 15 centimeter is my hypotenuse because that's the one across from the 90. The opposite is 9 because that's across from 37. And the adjacent is the 12. Okay? So let's see what happens. So they want you to find the following. They want you to take the opposite and divide it by the hypotenuse. So opposite divided by the hypotenuse. So if I have the angle 37, and this is my opposite, this is my hypotenuse, so I have to do 3 divided by 5. Right? Because my opposite is 3 and my hypotenuse is 5. So to find this in decimals, what's 3 divided by 5? 0.6. Okay, now we're going to have to do the same thing for the other triangle in triangle XYZ. I have to find the opposite divided by the hypotenuse. So what is it? What's the opposite? 9 divided by, and that gives me what? 0.6. What's angle A equal to? What is angle A? 37. So on the calculator, I want you to plug in sine 37. What does that give you? 0.601. All right. Now let's look at the adjacent divided by the hypotenuse. So what's the adjacent in the first triangle, in triangle ABC? 4 divided by 5. What's 4 divided by 5? 0.8. And then in the XYZ, 12 divided by 15, and that gives me 0.8. Now, find cosine of 37. What's cosine 37? 0.798. Have you guys noticed anything? Yeah? Okay, let's do the next one. What's the opposite over the adjacent? Opposite 3, adjacent is 4. What's 3 over 4?
0.75.
And in triangle XYZ, I have 9 over 12. Anyone doesn't know where I'm getting all these numbers from? We're good? Now what do I have to do for the last part? 10 of, what's 10 of 37? 0.753. Okay, what have you guys noticed? They're the same triangle. They're similar triangles, right? what did you notice when you did the opposite over the hypotenuse for both triangles? Turns out to be the same, right? And the reason for that is because I have the same angle. I have both angle 37. Now when I did opposite over hypotenuse and I did sine 37, can you compare these two for me? They're the same, right? They're the same. The only reason why this is different because the angle could be 36.9. Okay? But then because we can't leave angles with the decimals, we change it to 37, it gives you a little bit different. Okay? Now, how about adjacent over the hypotenuse? If I did adjacent over the hypotenuse, it turned out to be like what? 0.8, which is similar to cosine 37. And then when I did the opposite over the adjacent, it turned out to be the same as tan of 37. Now, is this going to happen all the time if I have similar triangles? Yes. The thing is, eyes on me right now. You see these formulas? Right? It's going to turn out that the opposite over the hypotenuse is going to always equal to sine of the angle. And the adjacent over the hypotenuse is going to equal cosine of the angle. And it's going to turn out that opposite over adjacent is equal to tan of the angle. Okay? And this is where the formulas, have you guys heard of SOHCAHTOA before? This is where SOHCAHTOA comes from. Because look at this. S-O-H. So. C-A-H. Cat. T-O-A. Toe. So if you've heard of SOHCAHTOA before, it's because it's an acronym of sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tan is opposite over adjacent. Okay? SOHCAHTOA. Okay? Remember that acronym. Okay, can you guys remember that SOHCAHTOA? Can you remember the formulas? Okay. Now, trigonometric ratios can be used to calculate the side of a right triangle if an angle and other sides are given. So I need to know an angle, and I need to know a side so I can find the other side. Let's look at some examples. So I have this triangle, it's a right angle triangle. I know that because of that square here in the corner. Right? And I know an angle, and I know a side. The first thing you want to do, you want to name your triangle. You want to name it with the opposite, adjacent, and hypotenuse. Okay? Because angle 65 is at the bottom, my opposite is right here. And then this is my hypotenuse because it's across from the 90 degree. And this leaves me with the adjacent here, which I don't really care about because I don't need to find it. What side do I need to find? The hypotenuse, right? Because it's labeled with the letter X. Okay? So they told me to find side X, and side X is the hypotenuse. Eyes on me for a second. What do you know? What side do you know? The opposite side. What side are you looking for? Hypotenuse. Because you know the opposite and you're looking for the hypotenuse, which one of SOHCAHTOA has opposite and hypotenuse in it? Sine. So that means, because this is the two that you're looking for, or you know, you're going to have to use the sine ratio. Okay? So, OH. Okay? OH, so opposite and hypotenuse, that's why I have to use sine. Does that make sense to you? So, sine is, always when you write sine, cosine, or tan, you want to write the angle with it. So that's why we write sine theta is equal to opposite over hypotenuse. Do I know angle theta? What's angle theta? 65. So I'm going to replace theta with 65. Do I know the opposite? What's the opposite? And I'm looking for the hypotenuse, right? Okay? So you see how you're going to have to pick the formula that you have to use depending on what's given to you and what you need to find. So you see I only have one unknown, which is the hypotenuse. Now what do you want to do here? What do you think you need to do here? Yes? Find sine 65. Find sine 65 for me. So how many decimals do I have to put there? I have to at least have 4, right? So what's sine 65? 0.9063. Okay, now what do you want to do next? Yes.
Multiply the side 0.9063 by 15. Get the hypotenuse.
Divide what? Okay, you want to isolate for the hypotenuse. Okay, so that means you want to bring the hypotenuse to this side. When I bring the hypotenuse to this side, it's going to be the hypotenuse times this. Okay, so that's going to be bringing the hypotenuse over here. It's going to be the hypotenuse times 0.9063 equals to 15. Now, how do you get rid of this? You bring it over and it's going to become 15 divided by 0.903. So it's not the other way around. So it's going to be 15 divided by 0.9063. Can I just tell you a trick here? So instead of doing all of these steps, you see how the hypotenuse and the sine 65, they switch spots. You see how they switch spots, right? Always if whatever you're looking for is in the denominator, right? I'm looking for the hypotenuse and it's in the denominator. What I do is I switch their spots. So I bring the hypotenuse over here and I bring the sine 65 down here. Only if you're looking for the denominator. So you see this? They switch spots. Can you see that? Yeah. So you can technically skip this step if you want. That will be skipping this step right here. All right, what's 15 divided by 0.9063? What is it? 16 point? So 16.6. Because remember that side length should be to one decimal place. And you should round it properly. If it's 16.55, that's 16.6. Now what else do you need to include in your answer? Huh? Centimeter. You need to include units. Because 16.6 kilometer is different than 16.6 centimeter. And I need to know what your answer is in what unit. Okay? You think you can take some time to try the next two questions? Okay?